Hello again, and we're going to introduce you now to the next stage in development of the flowcharting. Uses the mimic called level crossing. You see we've missed a few out. Well, these ones give us the next introduction, if you like, and in this case it's going to be movement. We see we've got a depiction of a kind of train set, and then we can see that the train is just poking out the tunnel on the far side, and we notice, if we are observant, that we have two inputs alongside the track, trip A and trip B. Now these are generally used in railway systems such as the Metrolink. They're usually embedded in the surface between the tracks, and you can see them at stations, Metrolink stations around the network, and they determine whether a train is there or not, or a tram. Now this system uses these triangles, and as the train passes the triangle by the track, it trips it or triggers a sensor. So trip A and B are our inputs. So we must ask the question whether these inputs have been triggered in order to start the sequence off. Now, the train doesn't move automatically. It will begin its circular route only when we've completed the flowchart. So we can't see much happening at the moment, but we can possibly, if we wrote a very simple flowchart with a start, and if we went to an output, just to turn the light on, any light would do, I think, just say on, and if we then loop back to the beginning, it's a nonsense flowchart, but it will allow the train to come. And we see the illumination of trip A as the train hits it, and it will pass, and it will hit trip B after the crossing, and then unseen it loops back on its track and continues on its journey. A few seconds later, emerging from the tunnel endlessly. So that's it, that's what we're looking at, trip A and trip B. Now, what we want to happen is a sequence of events once trip B is triggered. We need trip B, and there's about 8 seconds between trip A and the train mowing down the people on the crossing. So we need a number of things to happen. We need these signs to start flashing. We then, once the signs have flashed for a few seconds, need the barriers to come down. And only then do we want the red light here to turn to green to allow the train to carry on through safely. And once the train hits this last trip, trip B, we want everything to stop, the lights to stop flashing, the barriers to open, and the light here to turn back to red. That's the sequence that we want. And it involves subroutines, our old friends. And the first thing we need to show you though would be movement. So movement is a new type of output, and we see it's down here with barrier. So if Mrs. Booth will just put movement in, we can see that by operating the barriers, we can get the barriers to go up and down. So let's begin with, is trip A on? Now that's asking the question about this sensor here, and if the answer to that is a yes, then we want to start a sequence of events which will end up with the train passing through safely. So if the answer is yes, what do we need to see? Well, first of all, the left and right lights refer to these red ones here. Now that's not what comes on first. If you've ever been through Navigation Road, which is the nearest type of crossing like this to this school, you'll know that the first light to come on is this lower amber one. So we want the amber light to come on first. So we want that one on, and we need to turn all the others off, but we also want the red signal on, so the train won't pass. The green signal off, and the barrier should remain off at this point, which would be open. So that's the basic start point from when trip A is begun. Now we need that these amber lights, we want them to stay on for a time period, and a couple of seconds is all we've got. So we'll try 2 seconds as a delay.
This is in fact a better way to start up this first section of this rig.
And after that, we need the red lights to come on. Now, we have a series of events, and at this point you might be thinking, this is going to be an incredibly long process of writing these. Now, would it not make sense at this point, trip A on, to jump to a flowchart that can occur, or a subroutine? And this
is my recommended way of setting out all of these subroutines to make this mimic work properly.
I think the point that we need to start thinking and planning rather than just doing it in one go. We will all do this differently, and it is rather complex. So I think we probably would be best if we open a working one and talk through. It will be difficult to copy and very, very rewarding if you could copy it. So let's open one that I've done earlier.
This is the solution, or one possible solution that I came up with, and it works really well. You could try copying this, or you could complete your own version of this. It's largely up to you at this point, and everybody could do this in a slightly different way, and that would be absolutely fine. This is a close-up of how to move the barriers. You can see that there is an FD button, stands for forward, that moves the barriers down, and rev moves the barriers up. And next to it is a box where you put the percentage speed, and 100% is the advised speed to set that to. So forward to go down, reverse to go up. To end is a video that I took on my phone and uploaded, which is a great way if you want to do the same to show me what you've done at any point. I'd love to see the sorts of things you can do. And remember, once you've done this barrier crossing one, you can incorporate it really well into the more complex train sets 1 and 2 that follow on. So just have fun with this now and see what you can create, and I'd love to see what you manage to do.